Hello everyone, welcome to TypeScript Today. Today we're going to look at the difference between these two types. So what is the difference between these two types? Well, the first one is an interface that has a method, and this method accepts a parameter that is of type string or null. The second type is very similar, except it doesn't have a true method. It has a field that happens to be a function. So what is the functional difference between these two? Well, at call site, there isn't much difference between these two. We can call both members with the same thing, either a string or null. We couldn't call it, for example, with a number. However, there is a difference between these two when it comes to actually implementing this interface. The difference comes down to the fact that methods have their parameters checked bivariantly, while function signatures have their parameters checked contravariantly. And I'm going to leave a link in the info with a talk that I gave specifically about variants in TypeScript. But we're just going to examine this particular case right now, and we're going to look at exactly what the difference means in practical terms. So let's have a look at the method case. Let's say we have our human interface, and we're going to implement this interface using an object literal. Now, if we don't say anything else here, P is going to be string or null, as it should be. If we're going to be explicit about our parameters, we could say here string or null, and that is fine. We could also use a wider type here. For example, we could say that this method accepts string, null, or number. Now, we're going to alias this implementation behind our human interface. So when we actually call this method, we won't actually be able to pass in a number. We will still be able to pass in just string or null. But our implementation could, in theory, also handle a number, even though, because we're aliasing behind the human interface, it won't actually ever get a number. But here comes the strange part. Not only can you specify a wider type for our implementation, but you could also specify a more narrow type for the method parameter. So for example, we could pass here just string. So now our implementation can't actually handle null, or it doesn't have to handle null. So here we could, for example, call p.toUppercase, and TypeScript wouldn't complain because p is string, so we don't have to do any null checking. If we were to have had here string or null, then TypeScript would have complained, but we don't. And this is the bivariant part of method parameters. Namely, as long as the two parameter types are related, as long as the implementation type is related to the declaration type of the interface, it doesn't matter what direction the arrow of inheritance points between these two types. So it can be either, the implementation can have either a wider type or a narrower type, and TypeScript will still be happy. We can't specify here any type. For example, if we add string or boolean, this isn't actually valid because TypeScript will complain that these two parameter types are not compatible with each other. But as long as there is any relationship, any inheritance relationship between these two types, between the implementation and the declaration type, TypeScript will not complain and it will be happy to accept this. Now, this is obviously not safe. For example, line 12 will cause a runtime error even though our TypeScript program checks out. The types are consistent as far as TypeScript is concerned. So what about fields that happen to be functions? So if we convert this to a function signature, now the function signature will have its parameter types checked contravariantly. This means that our implementation could potentially specify a wider type or the same type. So for example, if we specify here string, null, or number, this is valid. TypeScript will not complain that the parameter type is not compatible. But if we try to specify a narrower type, TypeScript will complain about this and it will tell us that this method cannot actually implement that signature because the declaration signature accepts string or null, and our method only handles the string. Just one small detail, this behavior of having contravariant checking for parameter types is actually enabled behind a flag, behind the string function types flag, which you're probably already using if you're using strict mode for TypeScript. So you don't have to worry about enabling this explicitly, it's already enabled under strict. However, you could potentially disable this behavior if you don't want string function types, although I don't recommend doing this because you will be exposing yourself to potential runtime issues. So why does TypeScript have this bivariant behavior for methods? The answer is that if it didn't have this behavior, most classes would end up being invariant. The most clear example there is array. Array is a generic type, and since that type is used in both method parameters and in return types, what will happen is that if contravariants were enforced on method parameters, array would become invariant. And this will mean that we couldn't actually assign an array of cats, for example, to an array of animals. And this would result in surprising behavior for developers. So TypeScript allows this kind of behavior even though it's not strictly type safe. Thank you very much. I hope this was interesting. Looking forward to seeing you next time.